In this lecture, we will talk about another family of data model, decision trees. Decision trees are very commonly used in practical data analytics, predictive modeling tasks. It is pretty welcomed by practitioners like doctors and business people, as it tends to be able to deal with a mixture of data attributes, and they are good at generating interpretable data models. We will, in this lecture, we will consider the theoretical part of the decision trees. You'll probably be able to find abundant of information about this family of model, while our focus is more on the theoretical part, the design principle of decision trees, why it works, and the implementation details. So we start with how decision trees were motivated in the first place. What originated the design of this family of data model for predictive tasks? We start considering the ultimate format of a predictor. So not surprisingly, the goal of a supervised learning is to get something that can give us the values for the target variable. And from this regard, we can consider learning is a process to organize information about the target values from the experience of observed models, observed data. Let us focus for now only on the very last step of the target value production procedure. That means we want to give out one particular target value. In an ideal world, we can say if only we knew where to look at to retrieve the particular target value we should produce. Say, if we know down to the earth, if we know the memory address in a digital computer where the desired target value is stored, then we can retrieve the particular value and output it. That is, of course, not addressing the challenge we are facing, because we do not know which target value we need to produce. The question is, we are given some x, the attributes of the observable attributes of the data, and our goal is to somehow find the target value for the particular observed information. A naive solution to the problem of to find somewhere to look at for the target value is to meticulously record all our experience in a digital computer's memory. Then, in this case, we do have some. For example, for the moment, let's not. Let's say we have a magic memory that for 1 unit of the memory we can store all the observed attributes and the associated target value. Say in each unit of the memory we get a data sample, and there are attribute values and there is a target value. Then we will be able to produce target value given the attribute values. we can look up in this table from an attribute value, which of course in this case the memory address is not necessary, but just for as an index. Let us see, for the particular value of the attribute we get an address, and from this address we generate the target value. This, of course, you can imagine, doesn't address what we want, the ultimate challenge, what we want to resolve, because we immediately hit the wall of no generalization. The purpose of learning is not only to be able to reproduce whatever has been provided in the training data. The purpose is to be able to generalize to where the training data does not explicitly provide. So we don't like to memorize the observations. We'd like to summarize it. Therefore, instead of this physical memory-like way of organizing the information in the training samples, we want to build some kind of associated memory. We want to summarize some of the training samples into one block. Say we have some way to figure out those belongs to a similar region in the data space. For this data space, they are all associated to the same unit of information. Well, I think I'd rather to adjust my slide. Let's merge the two cells to make this more explicit, and of course they have now shared the same target value. So association between the attributes and target can be established in this way, where we by investigating the values of the attributes, we equivalently produce some encode of the information in the attributes, and those encode is linked to the desired target value. So this paradigm of design is not only used by decision trees, it reappears in multiple approaches in general machine learning field. In decision trees, this practice is implemented by cleverly design a series of right questions to ask, and the answers to those questions naturally serve as the virtual address links that connects the information from the attributes to the desired output value. And the smart design of the series of questions has used the principle of measuring the information in the summarized groups of data samples, particularly the information of the summarized subgroups with respect to the target value, and how to incrementally ask more such smart questions about the attribute values, so to improve the purity, the certainty of the information about the target value. Eventually, you achieve a tree-like structure by following one root in the tree. it is like the address finding procedure in a digital computer. Only now, the that kind of a memory is not as a hard-coded memory. It is associated memory built from the training examples. So in the next, we'll look at the details of what is a decision tree predictor and how to build such a predictor from training samples. One way of how to build it. There are multiple ways to build decision trees.